day everyone, I am Francisca Lamosti Bahenteng, and in this video we're going to focus on finding the volume using the shell method. Let's begin by drawing a picture. Excuse. So now we're going to find the volume when rotated the y-axis. The limits of integration is going to be from A to B. Then the radius is the distance between the x-axis and the axis of the rotation. So you should always draw the rectangle parallel to the axis of rotation. So in this case, you want it to be parallel to the y-axis. So this is going to be the height of the shell or the rectangle. This is height. So using the shell method, the equation is this. V is equals to 2 pi integral from 2 r of x times h of x dx. So if you want to find the volume of the solid when rotated about the y-axis, this radius and the height have to be in terms of x. And sometimes you have two curves as opposed to one. So let's call the top of curve f of x and the second curve is g of x. So we want to rotate it about the y-axis so that the rectangle is going to be parallel to y-axis. So now the radius is still the distance between the rectangle and the axis of rotation. So radius, this is radius, and this is going to be the height of the shell. This is height. So the only difference of this situation is that the height of x is basically equal to the top function of f of x minus the bottom function of g of x. So h of x equals to f of x minus g of x. So now sometimes you may need to find a volume when rotated about the axis. So now we're going to draw the rectangle parallel to the axis of rotation, that parallel to the axis. The radius is the distance between the rectangle and the axis of rotation. So this is the radius. The height is parallel to the axis of the rotation. So this is height. So the volume is going to be V is equals to 2 pi integral from C to D r of y times h of y dy. So keep this in mind. If you want to rotate the curve about the x-axis, the radius and the height has to be in terms of x for this to work. So let's say that we have the curves of y is equals to square root of x, and a region is bounded by the curve, the line of y is equals to 0 and x is equals to 4, and we're going to rotate it about the y-axis. So let's draw a rectangle. This is the height height na siya. So x is 4. And rotate into y-axis. And then the reduce is here. Reduce. Notice that the reduce is the same as x, so thus we can say that r is equals to x. Then notice that the height is the same as y, so y is equals to h is equals to y rather. So now if we rotating the y-axis or about any line parallel to the y-axis, the radius and the height has to be in terms of x. So now the radius is already in terms of x, which is good. So we just go to convert y into something in the terms of x. So now we know that y is equal to square root of x. So we can replace y with root x. So now we have h in terms of x. So let's use the formula. V is equals to 2 pi integral of from 0 to 4 x. So now if x is basically to the first power, square root x is x to 1/2. So whenever you multiply by common bases, you need to add the exponent. So x raised of 1 and x raised of 1/2. So 1/2, 1 plus 1/2 is equals to 2 halves plus 1/2 is equals to 3 halves. So therefore, we can rewrite the expression like this. V is equals to 2 pi integral from 0 to 4 x raised of 3 halves dx. So 2 pi x raised of 5 over 2 times 2 over 5 limits from 0 to 4. So 2 pi, let's substitute 4 and 0 to x. So 4 5 over 2 all over 5 minus 2 times 0 raised of 5 over 2 over 5. So 4 raised of 5, that would be 4 half 5, so 2 raised of 2, so 32. So we have 2 pi 2 32 all over 5 is equals to 2 pi 32 times 2 is equals to 64 over 5. So the final answer, that would be 128 pi over 5.